Welcome to Physics online class. How are you students? Fine. Very good. So last class we have learned about length, mass, time, temperature, then rules and regulation for writing SI units and their symbols. Did you learn, students? Very important question. Those who did not learn, just learn. Okay. Today we can learn about vernier caliper. We use a ruler or a scale to measure length and breadth of an object. Do you think this gives you the correct measurement? However, sometimes we should not get the correct measurement. In the year 1630, French mathematician Pierre Vernier invented a measuring tool to get a conditional accuracy in the measurement, combined to a simple rule. After his name, it named as vernier caliper. Vernier caliper is convenient tool it will use when you measure the length of an object. The outer diameter of a spherical or cylindrical object, the inner diameter of the pipe, and the depth of an probe. The vernier caliper are mainly consist of finely polished rectangular steel scale. This scale is called main scale. It is generally 15 centimeters long and the one end of the scale has a jaw. J1 is fixed and it commonly called fixed jaw. A metal frame on the right side at a fixed jaw. J1 which can slide along the main scale. This metal frame sends us vernier scale. It has 10 divisions marked on it. Here we notice that the 10 divisions of the vernier scale are exactly equal to the 9 divisions of the main scale. In the other hand, the vernier scale has a movable jaw J2. You see a retainer on the bottom edge of the vernier scale. This retainer is supported by a spring. A spring action at the bottom helps in the fixing a vernier scale at any desired position on the main scale. The instrument is also provided with two more jaws, J3 and J4 respectively. The J3 is fixed jaws and J4 is movable along with the vernier scale. Jaws J3 and J4 are called internal jaws. Jaws J1 and J3 are called external jaws. This is the vernier caliper. Okay, so vernier caliper consists of a thin long steel bar graduated in centimeter and millimeter is called main scale. So main scale vernier caliper consists of thin long steel bar graduated in centimeter and millimeter is called main scale. So this scale is called main scale. Okay, this main scale total 9 divisions are there. Then to the left end of the main scale an upper jaws and lower. See, this is the upper jaw, this is the lower jaws. Okay, two upper jaws and two lower jaws are there. So two upper jaws and two lower jaws. So this is the vernier scale. This vernier scale has 10 divisions. Here mentioned 10 divisions are there. Vernier scale has how many divisions? 10 divisions are there. Okay, so this is the retainer. What is this? Retainer. Okay, retainer. Just by using this retainer we can move this vernier scale. Okay, so we can see now how I am moving. By using this retainer we can move this vernier scale. This vernier scale just slide upon the main scale. Okay, just slide upon the main scale. Now you can see this the upper jaw. This upper jaw is used to measure the internal dimension of an object. lower jaws are used to measure the external dimension of an object. Okay, two jaws are there. So these two jaws are fixed jaws, this movable jaw. By using this retainer, we can move here and there. Okay, we can move here and there. So what is this? Retainer. Okay, so what is the use of this upper jaw? The upper jaw is used to measure the internal dimension of an object. What is the use of lower jaws? The lower jaws are used to measure the external dimension of an object. Now look at here, this is the depth probe. Okay, what is this? Depth probe. Do you know all the parts? Now this vernier caliper consists of two scales. What are the scales? Main scale and vernier scale. Two scales are there, main scale and vernier scale. What are the two scales? Main scale and vernier scale. How many jaws are there? Two jaws, upper jaws and lower jaws. See, these two jaws are fixed jaws. These two jaws are movable jaws. What is this? Retainer. What is the use of retainer? To move here and there. Okay. So what is this? Depth probe. The use of depth probe is to find the depth of an hollow object. We can keep here object. In between the two lower jaws, we can keep any object. Or spherical or cylindrical object we can keep in between the two lower jaws. Can you understand the description of a vernier caliper? Once again, it consists of a long thin steel bar graduated in millimeter and centimeter is called main scale. Okay. So the vernier scale has how many divisions? 10 divisions are there in a vernier scale. The vernier scale is slide upon the main scale. Okay. And now two jaws are there. One is the upper jaws and lower jaws. So these two jaws are fixed jaws, this movable jaws. Upper jaws are used to measure the internal dimension of an object. Lower jaws are used to measure the external dimension of an object. So what is this? Depth probe. Say all of you, depth probe. So what is the use of depth probe? To find the depth of an hollow object. What is the use of depth probe? To find the depth of an hollow object. Now listen here. See, this the ball. Okay, cylindrical ball. So to find the diameter of this ball. So just you keep this in between the two lower jaws. Okay. See, to find the external dimension of an object. Just listen. See how much depth this ball is there. That much. This is here depth probe. We can see the depth of an hollow object. Okay. So which object we are keeping here? Spherical object. A ball. No. This ball, how much depth is there? That we can see by using this depth probe. Okay. So this is the description of a vernier caliper. Next one, the usage of vernier caliper. How to use this vernier caliper? First, we find the least count and zero error of a vernier caliper. Okay. First, we should find the least count and zero error of a vernier caliper. Now, what is the least count of the vernier caliper? Is 0.1 millimeter. What is the least count of a vernier caliper? 0.1 millimeter. This write in centimeter means 0.01 centimeter. Okay. In the millimeter, 0.1 millimeter. In centimeter, if we write means 0.01 centimeter. Now we can find how we can find this value. Okay. So the formula for least count. Least count I am writing LC. Okay. L means least, C means count. Least count of the instrument equal to the value of 1 smallest main scale division. See the value of 1 smallest main scale division divided by total number of vernier scale division. Now see this the formula for least count. Least count equal to value of 1 smallest main scale division divided by total number of vernier scale division. What is the value? Value of 1 smallest main scale division is 1 divided by total number of vernier scale division. How many divisions are there in a vernier? 10 divisions. No, vernier scale has 10 divisions. So 1 divided by 10. So 1 divided by 10, what's the value? 0.1 millimeter. This write in centimeter, 0.01 centimeter. Okay, like this we have find out least count. Understand all of you? How to find least count? The formula is least count of this instrument equal to value of one smallest main scale division divided by total number of vernier scale division. So the value of one smallest main scale division is 1 divided by total number of vernier scale division 10. Just 1 divided by 10, value is 0.1 millimeter. This write in centimeter, 0.01 centimeter. Next we can see zero error. First we find out least count, next zero error. How to find the zero error of a vernier caliper? Now see, the two jaws are in contact. Okay, two jaws are in contact. When we find the zero error, first two jaws are in contact. The zero of the vernier scale is coincides. Coincides means two also same line. Okay, the zero of the vernier scale and the zero of the main scales coincides each other, then there is no error. Okay, first there is no error. So no error means what? The zero of the main scale and the zero of the vernier scale just coincides each other, there is no error. How to find the zero error? First two jaws are in contact. The zero of the vernier scale is coincides with the zero of the main scale, there is no error. There are two types of zero error are there. First one is the positive zero error. What is this? Positive zero error. Next one is negative. This first one positive zero error. Second one negative zero error. Okay, there are two types of zero error. One is the positive zero error. Next one is negative zero error. Okay, the positive zero error formula n into LC. What is the positive zero error formula? N into LC. Negative zero error formula minus of 10 minus n into LC. Okay, positive zero error formula n into LC. Negative zero error formula minus of 10 minus n into LC. Next we can find first one, how to find the positive zero error. Now listen, positive zero error, this is the vernier scale, this main scale. Okay, the zero of the vernier scale is shifted to the right of the main scale zero. Look at this, the zero of the vernier scale is shifted to the right of the zero of the main scale is called positive zero error. So like this, there means we should say that is a positive zero error. Okay, once again, the zero of the main vernier scale is shifted to the right of the zero of the main scale is called positive zero error. What's the formula for positive zero error? N into LC. What's the formula? N into LC. N means number of divisions. That LC means what? Least count. What's the least count of a vernier caliper? 0.01. Okay, the positive zero error formula is N into LC. Now listen, here fifth line is coincides each other. Do you see the fifth line? The zero of the vernier scale 5 and this main scale also 5. The fifth line coincides each other. So instead of N, you have write 5 into, what is the least count? 0.1 millimeter. Just to multiply 0.5 millimeter. Okay, this zero error. Zero correction means minus 0.5 millimeter. Understand? So zero error positive means zero correction negative. Zero correction negative means zero error positive. Okay? So like this you have to find the positive error. Now look at this picture. This is the negative zero error. So this is the vernier scale, this main scale. Okay. So here the zero of the vernier scale shifted to the left of the zero of the main scale. Now see here, first right, here left. Okay. The zero of the vernier scale is shifted to the left of the zero of the main scale. Then we can say that is a negative zero error. What is the formula for negative zero error? Minus of 10 minus n into LC. Okay. So instead of n, we have to write here which line quant size. Suppose here 5, fifth line quant size. Fifth or sixth line quant size. See here, sixth line quant size means we get instead of n, you have to write 6. So 10 minus n into LC. Like that you have to find the negative zero error. See how to use this vernier caliper. First find the least count. Next zero error. Okay. After that we can see. Look at this vernier caliper. We can see how to use by using this vernier caliper. First, insert the spherical object. Okay, what is this? Ball. You know this ball. Okay, what is this? This is a ball. This ball insert the lower jaws, in between the lower jaws. Okay, all listen. Insert in between the lower jaws. This ball in between the lower jaws we should insert. Okay. Now just check the main scale reading. What is the main scale reading here? What value is there? Look at this. The zero of the vernier scale near. What value there in the main scale? That only main scale reading. Okay. So like this you have to find the main scale reading. Now just I am drawing the tabular column. Number MSR. MSR means what? Main scale reading. What is MSR means what? Main scale reading. The next VC. VC means what? Vernier constants. Say all of you, vernier constants. MSR main scale reading. VC vernier constants. Next one, VSR. VSR means vernier scale reading equal to VC into LC. Okay, just you have to multiply this two. Now, just to find MSR value, what value you will get? 6 you got. No? So, 6 you write here. Then, see this vernier caliper. Look at this vernier caliper. Here 10 divisions are there in a vernier caliper. No. Any one division's quant size here. That only VC value. Okay. Any one division quant size. Suppose here fourth division quant size. Here 10 divisions are there in a vernier scale. Fourth division's quant size. So, here you write this vernier quant size 4. Okay. Next VSR, how will you calculate? 4 into, what is the least count? 0.1. What value you will get is 0.4. Okay. Then next line, the formula is MSR plus VC into LC plus or minus VZC. This is the formula. Okay. MSR plus VC into LC plus or minus VZC. Suppose here there is no error. Okay, no error means no need to find out positive error or negative error. Okay, just you write the MSR value. What's the value? 6. So write here 6. Here plus VC into LC, what's the value? 0.4. So just add and write the answer. So 6.4 millimeter. Like that you will get the answer. Okay, like that we can find the diameter of a ball by using this vernier caliper. Now this ball diameter how much? 6.4 millimeter. Understand students? These are about the vernier caliper. Okay, related the same one problem also there, book back problem. We can do now that book back problem. Yes, Rome letter 9 numerical problem question number 2. Okay, Rome letter 9 numerical problem question number 2. Book problem there. So just I am reading the problem. Just listen how we can write it given. Okay, that we can learn. The main scale reading while measuring the thickness of a rubber ball using vernier caliper is 7 cm. So main scale reading MSR, it is given 7 cm. Okay, MSR value how much? 7 cm. And vernier scale constants, that is vernier constant VC. Constants how much given? 6. Okay, here given question given 6 and a vernier caliper main scale reading given 7. Okay, these two are given. The least count they won't give. We alone we have to write least count. Okay, so here centimeter, here MSR value given in centimeter. So least count also we should write in centimeter. So 0.01 centimeter. Can you understand? So from the question we have written what is given in the question. What you have find the radius of the ball you have to find. So directly we cannot find the radius. No, first we have to find the diameter of the ball. Okay, so first we can write diameter of the ball. What's the formula? MSR plus VC into LC. Here, zero error, zero correction not given. Okay, so the formula MSR plus VC into LC. Suppose the zero correction is given, just you can write the formula. Okay, so diameter of the ball equal to MSR plus VC into LC. What's the value of MSR? 7 cm. So you write here 7 plus VC, what's the value? 6 into least count value 0.01. Okay, so 7 plus, just to multiply 6 into 0.01. So what's the value? 0.06. So just add the value 7.06 centimeter. Don't write millimeter, centimeter. But here given centimeter, no, so you also write here centimeter. Least count also you have to write centimeter. What you have to find? Radius. Radius means what? Diameter hopefully radius. No. So write radius of the ball equal to, what's the value? Diameter divided by 2. What's the value of diameter? 7.06 divided by 2. Just you divide it. 7.062. So 2 3s are 6. Here value point. Here 5. Then again 6 3. So the answer is 3.53 centimeter. Okay. Can you understand this problem? First you have to write what is given in the question. Then write the formula. Then substitute the value. You will get the diameter of the ball. Okay, what's the value diameter of the ball? 7.06 centimeter. Now radius of the ball you have to calculate. What's the formula? Diameter divided by 2. Just you divide means you will get the answer 3.53 centimeter. Okay, this Rome letter 9, question number 2. Yeah. Now we can mark the question. Rome letter 7, question number 4. How will you measure the least count of a vernier caliper? Rome letter 7, question number 4. How will you measure the least count of vernier caliper? Sure. Page number 5. Least count of the instrument. Like that given now. Value of 1 smallest main scale division divided by total number of vernier scale division. The least count of the instrument equal to value of 1 smallest main scale division divided by total number of vernier scale division. The next write this least count equal to formula and substitute the value, right. Here see the main scale division will be in centimeter, further divided into millimeter. The value of the smallest main scale division is 1 millimeter in the vernier scale. There will be a 10 divisions. Okay. So first you write this formula. After that write the substitute the value and write the answer. Okay. So this question number Rome letter 7, question number 5. Students, today's worksheet for you. Rome letter 7, question number 4. How will you measure the least count of a vernier caliper? Already you marked now page number 5. That question you learn. And one problem, you have written now that problem. Rome letter 9, question number 2. Okay, once again I am reading the question. The main scale reading while measuring thickness of a rubber ball using vernier caliper is 7 cm and the vernier scale quantity is 6. Find the radius of the ball. Okay, what and all given here? MSR value given, VC given. So you have to find the radius of the ball. Okay students, thank you.